This lesson is all about ellipses. So yesterday we talked about circles. So we've had a whole chapter on circles. The radius is the same. It's always going to be the same throughout the whole circle. Remember ellipses, we've taken that plane and we've tilted it. So before it was perpendicular to the base of the cone, and now we tilted it. So we've elongated the circle. So there's two images that I want you to remember. An ellipse can go long ways. Okay, so along the x-axis would be the major axis, or an ellipse can go up or down, where along the y-axis is the major axis. So I want you to remember those two as we go through some of these key pieces. Now, if you look at the ellipse graphing form, it looks almost similar to what the circle formula was. We have that center, the HK, and it's also still got that subtraction symbol, so it's the opposite symbol of what is normally given. The one thing I want you to remember that an ellipse will always be addition. So it will always be addition. There will never be a subtraction symbol in front of either one of these parentheses. Okay? And it's always equal to 1. So if you look and you say, okay, I have only addition and equal to 1, then this has to be an ellipse. There's two new things that we have in here. It's our x and our y. Our other equation had just r. So if you can imagine, this is the x radius and the y radius. So if you see, if this is the center of our circle, it's in the same general region as the circle center, but our x radius is going to go along the x-axis. So in the long horizontal ellipse, our rx is going to be longer than our ry, which is the up and down axis along the y-axis. Okay, so let's only draw half of that. Oh no, I lost my circle. Oh man, I'm not a good ellipse drawer if you can't tell. So this is our x, and our short one here is our x. The vertical one is our y, and our long pink line here is our y radius. Okay, these are going to come into play later on. Okay, if you notice, they're both the denominator of the x parenthesis and the y parenthesis. The c is very, very, very similar to the Pythagorean theorem, and what this is called is the focal radius. Okay, the focal radius. So focal radius is found, okay, is two different ways. It really is different based on which radius is bigger. So if our x radius is bigger than our y radius, so this example right here, okay, then what we're going to do is we're going to take the square root of our x radius squared minus our y radius squared. Okay, now if our y radius is bigger than our x radius, so this example here, okay, so y radius is bigger, then we're going to do something very similar, but we're going to switch it. We're going to have r radius squared minus x radius squared. So really what this does is it prevents us from having a negative inside the square root. Okay, now f1 and F2 are our foci, our focal points. Okay? So how we find that is we take our center HK. Okay? And this is an example for when our X radius is bigger. What you're going to do is we found our focal radius by doing this square root, X radius squared minus Y radius squared. Whatever we get for that value, and if your X radius is bigger, we're going to change our X value. We're going to take our starting value, H, and add C to 1, and then we're going to subtract C to the other. Okay, now if our Y value is bigger, then we're going to change the Y value. Okay, so H would then stay the same, and we're going to make the changes to K by adding C and subtracting C. So let's try an example together. A lot of times it's easier when we do it together instead of all these different variables. Okay, so one thing I want you to remember is I will always give you the equation in graphing form. You will never have to solve for something that you would not normally do. So let's first identify our vertex, or our center. Our center of an ellipse, remember, we take from the top portion. So this would be -2, +4. So if we were to graph this on our graph, we would go to -2, +4. Our X radius is the denominator of the X. So I'm going to say this is Rx and this is Ry. So our X is 6, our Y is 3. So what we're going to do, since remember this is an elongated ellipse, because we would have our X value is bigger, so we would say from our center we move 6 units to the right, 1, 2, 3, 4, 5, 6, and put a point because it's our X value. And then from the center, 1, 2, 3, 4, 5, 6 to the left. Now our Y value is 3, so we're going to go 1, 2, 3 up and 1, 2, 3 down. So what we can do is, again, connect our points. Remember, it does not have to be perfect. I'm not a good ellipse drawer. I'm more of an egg drawer. But that's how we draw our ellipse. So let's go into solving for our foci points. Now we have to say which is bigger, Rx or Ry. In this case, Rx is bigger, so we would say Rx is greater than Ry. Okay, so that means that Rx comes first when we do our square root. So we would say Rx squared, which is 6, minus Ry squared. So when we multiply and simplify, we're going to get 27, 36 minus 9. And then you take the square root. Always round to the nearest 10. Okay, so when you do that, it's 5.2. So because our X is bigger, we also have to adjust X. Okay, so we always go back to our center. Our center was -2, 4. So I'm going to write that like this in each focal point, because then what we have to do is we take this focal radius and we have to add it to our center and also subtract it to our center. So what we would get, -2 plus 5.2, is 3.2, comma 4, and we would get -7.2, comma 4. So when we go back to plot these points, we're going to go 3, 1, 2, 3, 2 is just a little bit past the line, up 4, so there's 1 focal point, and then -7.2, up 4, and that is our second focal point. So you don't have to label them, but what I want is for you to at least plot them. Okay, so if you have different colored pens, this probably would be easiest to do it with those multicolors so we can really see what you're doing. So graph your ellipse in one color and your focal points in another. So pause your video, and on the next page there is the problem I want you to try. So what we have here is our center is at 5, -4. Our our x radius is 2, our y radius is 5. So I've gone ahead and plotted our center. Our x radius is 2, so we're going to go left and right 2, and then we're going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And go ahead and connect those points so it looks somewhat like an elongated circle. So we know that our y radius is longer than our x radius because it's along the y axis where it's stretched. So we can say that our y radius is greater than our x radius. So this means that when we find our focal radii, we have to put the y value first. So go ahead and pause your computer, find the focal radii, and what we're going to do is we're going to, with our full side, we're going to change the k. You're going to do 1 plus 1 minus the value of your focal point that you got. So go ahead and pause. So after you've simplified, you should get square root of 21, which gives you 4.6 for your focal radii. So since we've changed our y was bigger, we have to add this 4.6 to our y value. So we're going to add 4.6, and we're also going to subtract it. So when we finish this, we're going to get 5 and then 0.6, and then you're going to get 5, -8.6. So in a different color, we're going to go to 5 and then 0.6, so it's just like halfway up, so it's pretty close to the end point, and then 5, -8.6, so again, pretty close. And that's your problem. The last thing we're going to talk about is writing the equation of an ellipse. So one thing that we have to remember is that it's set up the same every time. We have an x squared plus a y value squared, and it's always equal to 1. So remember, we're always adding, and it's always equal to 1. The one thing that we need to know is our center, our x radius, and our y radius. So in order to find our center, I'm going to show you a little trick. If you were to draw lines down through your endpoints on both the major axis and the minor axis, they will intersect right at the center. So the center of this ellipse is -4, 1. Our x radius from our center, we count out 3. And then our y radius is 1, 2, 3, 4, 5, 6. So when we have our h and k, they go in here. So it's 8x minus -4, turns positive, and then y minus 1. This is our x, which goes with our x radius, so 3 goes in the denominator. Our y radius goes into the denominator here. We would set up example 2 the exact same way. Remember, it's always squared and addition. So you have 1x, 1y, and then it's always equal to 1. So what we're going to do is connect those dots again. So they intersect right here, which our center is now at 2, -5. And we need to find our x radius and our y radius. So x radius is 1, 2, 3, 4, 5, 6, 7. And our y radius is 1, 2, 3, 4. So when we substitute this in, we would say x minus 2 and then y plus 5 because it's negative. Our x radius is 7, our y radius is 4, and you have now written your equation. Your homework is number 23 through 28.